got loyalty, got royalty inside my DNA.
Cool, yeah, let's just start, because our introduction isn't going to be nearly as interesting as the content itself. So I'll start with the gentle introduction. Hello, everyone. Welcome to PL Talk. It is a weekly live stream that happens Fridays, usually 3 p.m. Pacific, although we've had other times before, always on Friday. And the goal is to give people who may not spend their days thinking about programming languages, programming tools, and compilers a taste of what's out there. Everything from what can I use today to what can I dream about in 30 years. And the premise initially was Hong-Yi is, so I'm Jean, I'm one of the co-hosts. That's Hong-Yi, the other co-host, and Neha is our guest, but Dr. Neha is our guest. So the premise was,
I just go by Neha, right?
I think it's important to address you by your proper Dr. Neha name. But yeah, the original premise was Hong-Yi had said he wanted to learn more about programming languages, and I said, haha, maybe we should do a live stream. And then somehow it happened, and we've been live streaming since last year. So, so I already said I'm Jean. So I was a professor in programming languages before this. I started a company called Akita Software. We do developer tools in the API space, very much applying some of the ideas that we talk about in this live stream. And then Hong-Yi, do you want to introduce yourself really quickly, and then we'll introduce our special guest?
Yes, I am one of the aforementioned people who do not think about compilers and programming languages all day, but wonder like, hey, what are some things I can actually use? Let's see, I'm currently a security engineer at Figma. And Neha, do you want to introduce yourself?
So I'll give like a hype up first.
Yeah, okay. Well, go ahead.
I had known of the Dr. Neha Rungta for years as doing some really cool work in the formal method space. So I knew about Neha's group Neha's group at Amazon is one of the best groups in industry doing like very cutting edge formal methods work that's actually running this stuff in production. The papers from their group I've been consistently extremely impressed with the whole time. It's actually a pretty new group. It formed like 5 years ago. Yeah, like 5 to 6 years ago. So it's like incredible what they've managed to do in the last 5 to 6 years, like verification, like all the way down the stack, verification of IAM policies, all kinds of really, really cool stuff. And so I'm hoping that today will give a taste of is like this stuff does run in production. It is very cool. One reason you might not have heard about it is it really has not been around for very long. And so with that, take it away.
Thanks, Jean, and thank you for inviting me. I'm actually very excited. This is I've been thinking a lot about like, hey, what do I talk about and what do I present? And one thing I wanted to do was do things differently because it's Friday and like why not? And so the best analogy I could think of like what's different is generally when you have somebody formal methods. It's like, oh, here's my cool, awesome technique and idea, and here's why it's so clever because we are, a bunch of clever people, and here's what you can learn, here's what you can do, and like that's what I call the Blockbuster Script for a formal methods talk. And like that's a blockbuster movie, like that's what you go see each summer, and like at CAB or like at PLDI or POPL, like and. That's a script. That's a script we all know. And so today I decided like, oh, it's time for some independent cinema and formal methods where we need our handheld. We need like, we don't know where this story is going. But maybe some parts are like, wait, where's the math? Where's the formal methods? And like the goal is for you to actually be confused, like as you would be in like one of those edgy independent movies, like where you don't quite know what the story is, what the script is. And so I'm going to start off by one thing Jean said is like how we're doing it in production. Now that's a different challenge and a different scale that we've attempted at Amazon in terms of our goal, our hope and dream was how do we make it one click? Where you just click a button. And now if you want to make it one click, you not only don't have to think about like, oh, are you a logician or a PL expert or a software engineering expert? Now, keep going down to do you understand compilers? Do you understand computer science? But now keep going, keep going. Like, oh, are you a data person? Are you a manager? Are you a tech manager? Or are you like a C-suite executive? Or are you just Jean's Crab Shack, who wants to, who has a pop-up and wants to advertise it and is building this, cool little business on the cloud? And the answer is all of the above. And that's the audience, that's the target. And it 3 years ago, when we said, hey, we want to make formal methods, automated reasoning, one click, it sounded like science fiction at the time. Like, it's like not only an independent movie, it's like, oh, okay, sure. But and hopefully by the end of the talk, you'll see like how like if you read a lot of good science fiction, if you go back and you say they are actually predictive of the future. So that science fiction like story did come true. So I'm gonna start here. Let me see if I can share my screen. Okay, this is gonna be a thing. You should see a little browser with just like a few of my S3 buckets. You have the cloud. What, for folks who don't know what S3 is, it's just storage in the internet. Like, think of like malloc for the internet. You can just go get however much storage you want, go and grab it. And like, here's I created this bucket just so that I'm not putzing around with it. I can say I have something called this is where I store all my data. Like, if I'm a company, a user, a customer, I store my data. It's sensitive. I don't want arbitrary people on the internet to have access to it. And so 2 years ago, we worked with S3 to design this feature called block public access, which means if you turn it on, it's one click, you turn it on. And if your bucket did grant public access, then it would block your data plane requests, because they're like, nope, you said you cannot grant public access to the bucket. Now, if you sit there for a moment and think, how did we do it? This is one of those, low latency tier 1 service, and it's using the result of an SMT solver in its data plane. Now, the SMT solver is not actually called in its data plane request, because that would you think, but it is called in the control plane request. So if you now try to attach a bucket policy that is public to a bucket, it's going to actually call an SMT solver in the backend. But if you look at this page, it's like, oh, so I can just click this, like clickety clack, right? I don't have to know what an SMT solver is, or what's happening behind the logic and frame. It's like, this is it. And I'm going to come back to it, but like this is where we started. We're like, okay, but that is one check. It's like, of course I don't want arbitrary people on the internet to have access, but Jean likes me. Jean might want to wants Neha to have access to her buckets, because there's cool collaboration and things we can do, but I don't know, she may not trust other people. Like, she's just like, oh, I don't know if there are other people she wants to. So to grant more finer grained access, you can say, oh, I'm going to write this policy because I'm going to author this access control policy that says I'm going to grant some people access. I am going to say, okay, let's edit my bucket policy. So I'm editing a bucket policy. I actually had a couple of samples. So let's look at what the structure of a policy is. It's a bunch of declarative statements. And this is a simple, everything is secure by default. So access is denied by default. So nobody outside your account has access to your bucket by default. So that's a security control. That's by design. But now we want to grant access. It's like, oh, okay, what do I want to do? Let's actually start with a larger thing and say, allow any actor, any principal, any user or role, any S3 action. We can make this like, let's make it S3 action, even though it's going to come back to it because we have it here. It doesn't matter. Like on this resource, this is my bucket, only if the request is coming from a particular VPC. So what's a VPC? A VPC is a virtual private cloud. It's networking for your cloud, rather than it being all the networking constructs that you think in the real world have been defined for the cloud. So everything can be described using APIs, and you can actually, do compute across the internet. Okay, great. So before I attach it, I want to know, did I do it right? Who has access to this bucket? Because this looks like a simple policy, right? But, so what are we going to do? We're going to click a button. What's this preview? I have this set up, so this might look fishy to you, but I'll do one later as well from scratch. So, it's like, okay, this is clicking. There, you see, I'm not writing a specification. I'm not writing any temporal logic. I'm just clicking a button. This is a button. And it gave me information. It gave me, principals, with the condition, have all this access. Wow, okay. Now I can go save changes because this looks legit. This looks like something I'd want to do. Now I'm excited, right? Like it feels like I suddenly can do things, like I have visibility into what I did. Was it right? Was it wrong? But now I know. It's like it was very declarative. So I want to study a bit more about this. What do I do? So this is just in the regular S3 console. I want to go towards, this is the identity access management console and I say, I go to Access Analyzer. That's what was running, Access Analyzer. It's built using SMT. Again, but for now, I'm going to challenge you. Can you, to say, if could anybody see the map, hear the map, smell the map, taste the map?
There was a question about the policy language. Someone asked if the policy language is really that powerful.
So the policy language is very powerful because it's one of those, it provides you very fine-grained access across 200 services, 6,000 actions with, it's one of the most powerful, like you can attach policies to different types of resources, your identities, your organizations, and then say, and really control access. So it can really unblock a lot of use cases. It's very flexible, it's very robust. But, given that it is so flexible, so robust, so powerful, you want something that says, hey, am I doing the right thing? And now that's something that smells like what we love to do in formal verification. Say, but how do you come up with a specification? The one-click paradigm doesn't allow us to say, can you just write me some LTL and CTL, and then I can tell you if your policy satisfies these. I mean, that's just not even the realm, but even having them write simple questions becomes really hard because it doesn't scale. It breaks our one-click model. So we launched this service called Access Analyzer in end of 2019, where the whole goal was to really flip the model of, where is it that the human does the work? And in a very traditional verification environment, you have the artifact that you want to verify, and the humans really go through and make the effort of saying, what's the specification? And then the machine gives you a yes or no answer. And what we are trying to do with Access Analyzer is really flip that on its head. What do we mean by that? We say the machine generates the specification, not just a single specification, the specification based on your environment. And it gives you a bunch of findings. It tells you, this is true of your system. Did you intend for that to be true? And now the human looks at it like, yes, this key I had given to my, neighbor who's now actually moved, and now, they're actually in trouble. So maybe, it's actually unsecure and I need to change the locks in my house. Rather than it putting the burden and asking, does my neighbor have my key? Because that would require that cognitive, just knowing the right question to ask. So with this shift, there's much richer information that's presented to the human, and the human is making the decision, this is what I intended versus this is something that I did not intend. So what does it actually look like? We saw a little policy. We saw, let's see, we're going to see what are my 3 buckets. Let's see, am I in the right account? Okay, we don't have findings yet. It's going to take a little time because it's, going to go create, it's going to trigger evaluation. We'll come back to that. So what's happening is when you created this bucket, it's going to actually generate a finding. And within 10 to 15 minutes, it's going to show up as a finding in your Access Analyzer console, which it's not there yet. So let's see if we refresh it. We'll wait for the finding to come up. Okay, while we do that, let's try to do something else and see what happens. Let's actually try to make this a more specific action, going back to the power of the language. Let's call this, I need to edit. Click my edit bucket policy. I say, now I have to actually apply it to the objects in the bucket because my resources. I can preview it again. It's going to create a set of new resources. It's telling me one of my original findings is resolved because it had a lot more actions. Because my original policy had like star instead of like a very specific one on S3 put object. But it says, okay, it resolved this one, but it generated a new one. And now it's saying the only access level you have is a write on the S3 put object coming for requests coming from source VPC. This is a made up VPC ID. So now, okay, I'm like, oh, great. Okay, now I can save the changes. Let's look at a few more examples. It's actually interesting. It also will demonstrate some of the richness of the language and where, having the power of SMT solvers really comes into play.
And there's also a quick audience question about whether the analyzer can help simplify policies as well.
So we just launched, they're not connected yet, but we launched a recent feature where it goes through and looks at your logs, like, hey, what are the permissions you used in the last 90 days? And it will say, oh, here's a template of a policy that only these permissions have been used in the last 90 days. Do you want to update your policy? So
that is super cool. Yeah, I feel like analyzing logs for permissions is just the way to go of the future.
Right, because like this is essentially like static analysis. Like it's like, this is what's possible, given your configuration. But the gap becomes like, you don't really know what will break if I remove or change something. And that's where we are leveraging information from logs to say, oh, you haven't really used it in 90 days. So go ahead, you can, essentially you don't need these permissions.
Oh yeah, that's amazing. I love that.
So that's another aspect of production, right? Like it's one thing to say theoretical, but like one of the goals in having a production system is you don't want your production systems to break. So like having a more of a 360 view of like, this is what your configurations are, this is what your policies are, and like combining all these different data sources, analysis sources gives you a lot of power.
Oh yeah, I'm completely on board with that. I feel like people often think of formal methods as something that you just apply before code runs statically, but I think applying it to traces, applying it to production traces, production logs is like the way of the future. Then you get, that 360 view.
Right, and by the way, right now on the logs, it's just log analysis. Right now, we aren't even doing anything like that's formal methods, but even that can give you such a big bang. And like over time, you can imagine, doing a lot more analysis on the logs to say, like combine, your existing policies as well as your log policies to come up with, even better least privilege permissions.
Yeah, someone in the chat said it's least privilege taken seriously. And
are your findings does Zelkova do this analysis like once in time, or does it actually do this, not the log analysis, but the findings that you were showing earlier?
So the findings, it does it on every change trigger. Like it does it on every change to your environment. It's about like, it takes a little time for the change notification to go through the system. It takes about, our SLA is about 15 minutes, where it says like, based on once you made a control plane change, it bubbles and like it listens to it. So it's continuous. But what we also do is a once every 24 hours anti-entropy scan. So it goes through and analyzes all your control plane configurations, your access control policies, and says, oh, did something change? And that's for, ensuring some event didn't get dropped. Like if it did get dropped, like it actually do catch everything.
Okay, cool. Does it how much does Zelkova like try to resolve dependencies against other accounts or like other external, like for example, you had a reference here in your policy to a source VPC that I think this one is fake, I think is what you said, or made up, right? I was just curious, like how much does Zelkova actually go and try to verify these external references, for example, when it's doing some of this analysis?
Fantastic question. I'm going to change my example to show you what it does.
Yeah, cool.
Let's do that. I think this is right. So this is a made up fake VPC ID, but like, you could have given me yours and it would have said, like it would generate that finding I showed you. So I'm going to show one thing. So essentially every account has their own VPC as well. So what I'm going is like, I'm going in my account, I'm going to the, okay, my session expired. Okay. Account, let's see. So I go to my VPC. It's telling me what VPCs I have. So this is one of my own VPCs, like this is within my account. And I'm gonna copy, like this is a real one. This is a real VPC that's in my account. And what I'm gonna do, go back to my S3 console. Hopefully it lets me go back. Okay. So you see here, I'm gonna paste that VPC ID. Like that came from my own account. I'm gonna say, okay, let's see what access analyzer gives me. It resolved it and it didn't give you a new finding, which means it's aware of everything within your account. And it's treating your account as a zone of trust. So the way security and like it's secure within your account. So secure by default means it's secure within the account and you can give access to people in your account. So, but you know nothing about people outside your account. So that's the what we call the zone of trust, or essentially your data perimeter, where like you want to know about access from outside your account. But here it's treating it as no.
Gotcha. Okay. Are there, I was curious if you have any, maybe we'll talk about this later, I was curious if you had any plans to support other security boundaries like organizations, for example, which might have multiple accounts as a very common practice.
So it does. So you can create an org analyzer at either an account level, or you can create it at an org level. So it'll say, oh, anybody outside my organization has access. So it doesn't aggregate, like the organization analyzer is not an aggregator across your accounts, but it actually aggregate, like it says now it treats a different, like a broader zone of trust boundary.
Okay, cool. I'd love to see an example later if you have the time.
And in the management account, you can actually delegate. So a lot of times, like organizations have like were traditionally used for billing constructs and like who controls it. So there's a very cool feature of like delegated admin where the management account can delegate to another account to say, hey, you can control this security aspects of the organization, and it's actually one of our most used. It's through an org's integration that we're actually seeing the highest uptake on people turning on Access Analyzer.
Cool. I think there are a couple of requests, which I'm also interested in as well, about can we talk about how the policies get encoded as SMT formulas?
We definitely can.
And I'm super curious about like where it runs in prod, like how this actually hooks in.
Yeah.
Yeah, absolutely. So let me actually maybe shift. So I'll let's see.
Also, something that I feel like especially this log analysis feature is very related to is a conversation Hangi and I have now and then, which is no one knows what the permissions should be. And so there's this, like the new way of understanding systems is this, what Mark on my team calls programming by observation. But it's like, you write some code, you take notes on like what actually, was true yesterday, what's true today. And that's what you have.
Yeah, it's like the empirical approach to programming, as it were.
Yeah, so I think it's super cool to be putting formal methods minds on empirical programming.
Are you seeing my screen?
Yes. It says demo time.
Okay. I'm actually going backwards. So since the question came up, so it does. So at the heart of it, what is Zelkova? It takes access control policies and translates them into SMT. And it uses the theory of integers, bit vectors, and what do we use in the backend? We actually use CVC4 Z3 and essentially a custom automata-based extension to Z3. And we're at the stage where it's like through the different integrations, block public access, we have integrations in guard duty, MACE, config rules, trusted advisor, and of course, access analyzer, where given and for each call, we race the solvers, like they're called in parallel, and whichever one comes back first is the one we give the answer to. So it's essentially now called, like, we have SMT solvers being in aggregate billions of times a day, and we've seen an exponential growth here. Like I recently had to update this slide deck. I've used this slide for a long time, and it used to say millions of times per day, and I'm like, wait, I need to change my millions to billions. And so I ended up. So at the heart of it, Zelkova is still very traditional, like where we said, hey, what do we do? Give it a policy, give it a question, and it gives back a yes or no answer. It's exactly the thing we said we didn't want to do, but like we had to start, like that's our bread and butter. Like we have to start with the basics of the formal methods movie making. And we had a rich type of policy language, identity policies, role trust policy, S3 bucket. And the questions were, hey, can user Alice launch EC2 instances? Can anyone outside my account assume this role to do this thing? Can user Bob delete files from a bucket? All these things you could imagine having questions about your access control. And before we talk about the encoding, it's very like, how does it actually work? How does the authorization logic actually work? You have a request, you generate a request, it comes in, and it's like, is it the case that it doesn't match one of the denies and matches one of the allows? And remember, everything is denied by default, like it's implicit deny. And here an explicit deny trumps an allow. So if I say allow Gene, and then if I say deny Gene, Gene's going to be denied because the explicit deny trumps the explicit allow. But if you think about this for a fraction of a second, this is very first order logic-y. Like it's, you have a bunch of conjunctions, you have a bunch of disjunctions, and all you have to do is like aggregate it. And we actually published an FMCAD paper on like I actually won't have time to go over it, but I wanted to tell people, it's, if you look at the encoding, you'll be like, that's so easy, it's simple. And at a meta level, yes, but what was the accomplishment here was, the policy language had conjunctions, disjunctions, negations, conditionals. Again, everything's logic, and you're like, wait, but now doing it at a language that has organically evolved for 10 years with the varied set of use cases across 200 services, and actually getting it to run in production along both a set of synchronous API calls as well as asynchronous API calls, their performance, like it actually impacts availability of the services, like getting it to be at that performance scale where how do you get, like for certain cases, how do you get the solver to not time out? We haven't.
Yeah, like those questions I'm so curious about, because like whenever I've worked with Z3, there's always the case it just runs. You don't know why it's not stopping. You go home, you come back in the morning, it's still running. And so running that in production is just nuts. Like the fact that you got it to work.
So what we do is we really leverage the domain here. Like and that's the true power. It's not the, how do you do it in the abstract? Like if like, this could be a grad student program where it's like, hey, read the documentation, come up with an encoding and like try to do it. They would get it 80% right and you could almost do it. But the differential between that to actually running it at scale in production, as a dependency to like the tier 1 services in AWS, like that was our true challenge. Was
yeah, like that's just crazy that your team managed to pull that off. It's just, yeah.
And part of it is like, so even today you're not free of it. Like it's not. So we track metrics really, really closely. Like, hey, what's our solve time? What's like the P99? Like, what's the P50, the P99? What's the, what are the P100s? Like, so we had to make this call. Like, okay, so the solver, we time bound it. It runs on Lambda. It's like, but like we time bound it. And also these are like, the good thing about these policies, they're all decidable. But you can still get things that are like, throw the solvers off. There's no loops or recursion. I mean, that actually does help. And when you get it, what do you do? And that's a question we have to really struggle with. And at the end of the day, it became not a question of, it actually became a question of like security and customer expectation. So if you attach a policy in S3 console, which is making it public, because now it's running it in the control plane and we have a timeout. And if it doesn't meet the timeout, like it actually says, your bucket is public. And it actually fails closed. That's the way, because it's a security feature. We can't say, I don't know, because it still has to give an answer. It's a preventative control. And so like that actually are the types of trade-offs and questions that as I wouldn't have thought of like 5 years ago as just a formal methods researcher, if I'm like not thinking about like scale and production and security and like what are the assurances we are making to customers about the feature. And I think it's a mental model shift for folks in PL or programming languages from methods. It's just like where the corners are. And I think I would really encourage folks to be thinking about usability and not think of usability as a second-class citizen where it's like, oh, it's about just a pretty UX. It's about coming up with the right abstractions. Like think about it as an abstraction problem rather than think about it as like, oh, why should I have to have like a pretty UX? It's not a UX problem.
Yeah, I love that. And I completely agree, because I feel like there's a class of problems a pretty UX can solve. There's a class of problems one click can solve. And then all the stuff you're talking about with running this in prod, it's really like, what trade-offs do we make to make this more usable? And I think that's so, so cool.
Yeah.
And so we had to come at it from all angles. Like you saw, we do have a UX where we like do run things, but once we came up with the right abstractions, the UX was not that hard to
Yeah.
like, it's actually the hardest thing, if you were to say, like in like launching Access Analyzer, was for us to define this notion of, oh, your account's your zone of trust. And that, like, we're going to treat every request, like we're going to try to extract from your policy what comes out of your, what's from outside the account. Simple, right? But we were in this Zelkova model, like, oh, like you ask your question and then we give you an answer. We were really stuck in, like, that's
Yep.
like,
yeah, no, that's actually, it's very subtle, but that's such a nicer way to set things up. Now that you pointed out, yeah. I'm also, I just realized the entire format of your talk, Neha, is very based on something I've been thinking about for a while now, which I don't know if you saw my SIGPlan blog posts on what is the role of developer experience in programming languages research. But one of my points was,
but I will.
Yeah, I'll send it to you after. But one of my points was, most of these papers, they have a tiny introduction about here's the user constraints that, like, most of the time are sort of made up to motivate the assumptions that people wanted to make. And then all of the evaluation is actually, how fast did things get resolved, or what are my proofs? And there's very little evaluation on, what are the actual usability elements of this. And something I love about both the way you structured this talk and how you're describing things is I feel like the entire design of Zelkova was made for everything to fall out very, very simply, but it's not inevitable that it was simple.
No, and in fact, I mean, this is why I actually started at the end. And this is why I said this is like this, handheld indie movie. Like, I'm actually not telling the story in chronological order. Like, if I had, be like, and we went through this, like, we have this powerful engine. And in the early days, we're like, hey, what can Zelkova do? It's like, it can do anything you want. Befuddled, confused looks is like, okay, great, thank you.
Yeah, that is the pitfall of, like, I feel like every fancy formal methods tool.
And we were right there. We were right there. And like it took like, and now if you look at Access Analyzer, which is one click, you can go to, like, you can essentially take one of the people in your company, or like essentially any person in a company. And one of the things, one of the greatest compliments I took was one of the VPs is like, oh, but this is so simple. I could turn it on. And I'm like, great. That's like the best compliment that I could have. And again, the click is not the UX. It's not the part of like the UX. It was the notion of the abstraction, the notion of having to say, this is your zone of trust. It's about shift. Like, I think there's I'm going to skip ahead for a minute to show this picture. This is our traditional verification effort, right? Like, we have the policy. I mean, that the humans got to write, because that's the intent. Like, there's no, there's some work we want to do here in the future, but like for the purpose of Zelkova, like that's where it is. Now there's a huge human effort that goes into the specification. And then you get to the verification where, like, that's where your machine, your reasoning engine, but the amount of information you get out of it is one bit, a yes or a no. Like, this is so much effort I put into it, and all I got is a one bit. And I don't even know, did I ask the question wrong? Did I even phrase it? Like, is it the right question to ask? Did I ask it wrong? And there's so many ways you could shoot yourself in the foot. And like, we really did try a lot of experts. Like, this was an expedition, right? Like, this was like, this was base camp for us. Like, if you were to like talk about like the true expedition, where it's like even getting to base camp's a big deal. And like, we were like, okay, we can get to base camp. We can really get smart humans to do this. Like, we can have experts or logic experts. We can get like consultants. Like, there's a whole professional services organization at Amazon who helps customers do things in their environment that are, that they want to achieve and accomplish. So we're like, okay, we'll work with that organization. We're like, okay, we can write these general specifications, right? Like, we can, the block public access is a great example of a generalized specification, or we can give templated specifications. We can say, oh, here's a template, just fill it out. But it all, like, this was the bottleneck, the human effort in the specification. And with Access Analyzer, our breakthrough really was that we flipped the model. We said, okay, the policy, it's still there. We're going to infer your specification. and verify it. And the human effort now is about, this is true of your system. Did you intend for it to be true? And now that's a very different question than like the one that we had. And this journey from the previous slide to this slide, like truly felt like, climbing Mount Everest for us. But this is a lesson I would want to like really preach or proselytize, for the lack of a better word, to the entire formal methods community. Is this is how we should be thinking about it. Like we should be treating usability abstractions as a first-class citizens, as a first-class citizen. If we want formal methods, tools and techniques to become the fabric of how computing is done, where it's not a separate field. Like we don't think of distributed systems as distributed systems. It's just there. And I think this is key.
Cool. I had some questions, and also some other folks had some questions, I think, in the stream about, I think, sort of what else Zelkova can do. So one thing that someone was curious about, I was also curious about this, is how do you, so you've solved this verification issue of like, does this bucket, for example, allow public access? So once you get there, does Zelkova, or are there plans to have Zelkova help users change a deny, like this bucket allows for public access, into what they actually want? Like, does it explain, hey, this is the policy that actually, or this is the part of the policy that allows public access, and this is the thing that you should change?
Not yet, and there's a reason for it. And partly it's logically, we could tell you, hey, change this, like like actually coming up with a transformation. You can imagine is actually a solvable problem. There's multiple, the challenges are, the biggest one, how do you know it's not going to break their production systems? Like, and that's the reason where we're like, oh, we need actual data, we need logs, we need to see what people have actually done, combine it with, before we actually say, because what you don't want is to like actually recommend a policy, somebody applies it, it breaks their production system, and then go, wait, this is not great. And now you can't go back and say, well, it's actually correct logically, it's just that, and it breaks the one click tenet that we have. Okay. Like it's like, hey, and you don't want to give things before they're ready, because that's another thing, because it's actually going to lose trust with people, like, oh, this actually doesn't work. The second aspect of it is, one thing we want to actually do is like say, ideally you shouldn't even have to do it. Like, how do we think about like better higher level constructs that you can express intent better? So like that's one other dimension. Like we actually want to say, let's bring more PL constructs, but not from a PL dimension, but more from a like usability, understandability dimension. Like when I'm saying define this new language, it's not about it's not about like, here's my perfect PL setup. In the same way, like access analyzer is not like about, here's my perfect verification setup. Like that's our dream, that's our goal, that's something that we want to move towards. Okay, cool. And I think this also ties back to what you were talking about earlier about sort of the developer experience. I'm wondering how much, like, is this tied to a broader effort to try to simplify, for example, Amazon permissions? I think everyone would acknowledge that AWS permissions are notoriously complicated. And so it is very common for developers to say, I can't figure out the secure least privilege policy for my new service. So I'm going to open it up. And I know it works when it's all opened up, and I can't figure out why it doesn't work when I remove certain policies. And then they sort of like hope for the best. And at some point, someone else comes in later and tries to lock things down. And obviously Zelkova helps with that effort. But I'm curious if, like, sort of going back to the beginning, is there a broader effort that this sort of ties into to try to make the, like you were saying, have better abstractions at the start? Absolutely. Make it easier to... And I mean, that's the goal. I mean, what you said is exactly the end goal, is not to have verification, but to have, to simplify permissions management for AWS users. And that can be through better abstractions, formal methods, log analysis, better UX, better primitives that can do things, and it's a whole spectrum that, and eventually, like as these things come together, like it's like the goal is for us to provide a holistic view where, you know, people don't actually have to think about permissions or think about even verification or least privilege, or like how do you how do you do things that are, you know, starting from construction of your systems to you know, its whole life cycle. So that's something that it's like we're pushing on across multiple dimensions to get to what we call like the simplified permissions use cases. And I know somebody asked like what the encoding. It's actually not complicated at all. Like, I mean, this is a simple, and this is what I said, hey, this is what a first order, like it's because it actually maps very nicely to like the policy language. It can get a little more complicated when you have wildcards, like like you do regular expression matching. So your constraints, that's where the complexity of your constraints get, because from all the string matching. But you can say, oh, these are two allow statements, so this is just a disjunction. You're like, oh, my principal is in this language of this, you know, it's 3-star, and which is in the language of my, you know, resource ARN, or that the principal is not. It actually is even more easier for me, at least, to understand the logical representation. And I sometimes still do, if I can't understand a policy, I look at the SMT encoding to actually understand what it is. And I've done it more than once to that end, just because like because without seeing those operators, like that's how my brain is wired. So for me, it's just much easier to see it in logic.
That's very clear.
Yeah, is the regex matching where the Automata extension comes in, is what someone asks in the chat.
Yeah, and some of it was like just we developed it for. I mean, we use string theory, but it's like it's not the whole undecidable string theory that's in SMT solvers. It's, you know, subset. There's only a subset of operators that are used, and again, because of the domain of the language, we know how they are going to be used. So we essentially so those are the types of things we leverage to, you know, Jean's point, like, well, you know, how do you run in production? It's like, you know, it took us a while, and like we, you know, we started here and like kept making it better, both in terms of the performance.
Cool. I suspect I know the answer to this, but I was curious, are there any plans to make like a Zelkova API more generally available, so that, so for example, you have some very clear security like invariants, like, oh, you know, does this bucket have public access or not? But I'm wondering if, you know, there are probably teams out there, mine included, who would like to be able to write our own security invariants and say, hey, this is a property of this particular configuration that we don't want to ever change, or at least we want to get notified if it does. But of course, that would require being able to write our own formula essentially and be able to ask Zelkova, hey, is this true at any point in time? I was curious if there are any plans to allow that.
Yeah, so we want to provide that capability, and what and we're going through this process now is in say, how do we, now that's not going to be a one-click solution, but even something that's not one click, it's like, how do we construct it in a way that it's really easy for you to ask those questions without having to be like, oh, I need to specify my security invariant or my governance rule or things. So that's where we want to, like, that's definitely where we're going next. It's just, you know, now we have a whole set of what is the right experience, what are the things because we want it to be applicable for like the millions of AWS users, because we can have expert customers, users be able to specify more complicated invariants. But now if that becomes like if that becomes too complicated, now we're like, wait, the goal was to simplify permissions. So that's the tightrope we're walking, and we are really committed to like raising the security that people feel comfortable and secure about their own permissions, yet really simplify the experience.
Yeah, that totally makes sense.
Yeah, so I have a couple of questions, one of which is based on a audience question. But the first one is, so you mentioned you're only in the decidable fragments of these solvers. And so what is the advantage of using a solver versus just writing your own heuristics for doing the solving? And the second question is, someone asked, if you're redoing this project from scratch, is there anything you would change to make it easier to resolve the permissions?
In the first one, there's been a lot of work gone into these solvers, like with great heuristics that really work a lot. I mean, at the end of the day, solvers use heuristics too, and they are really good. So, I mean, there's nothing that stops us from rolling our own, and maybe in the fullness of time, we might have, like, for certain use cases, but the point was it works. So
yeah, because I think like one question I'm wondering there is, it seems like using these solvers comes with a set of production trade-offs where you get well, I mean, I guess it's like what using Python used to be. You lose a lot of control, you have to make a lot of production time concessions, but you get all this work for free. And so, like, yeah, it's really interesting that it's worth all of the working with the timeouts and all that stuff.
And I mean, part of it is it isn't like it is something that we've thought about. Like, it's not like it's a very valid and good question, and it's something we've thought about, and it is something we're looking to invest in the future as well, to say, what would it take for us to have like, I would say, a specialized solver for because we don't, I mean, part of it is, one of the challenges as talking about trade-offs was like, they're general purpose solvers. They're meant to be general purpose, right? And then, and they have served us really well. I mean, as I mentioned, like, there's billions of calls a day, which to me almost seems we might be at the top end of the spectrum on like any industrial system calling SMT solvers.
Yeah, that's insane. Yeah, that's so high.
And so, but as we grow, like, and to me, the interesting point is, like, I would say we're still, if you ask me today, I'm like, oh, we're just at the beginning of our journey in terms of the use cases that we can even think of. And like, even what the immediate next step use cases are just the beginning. So absolutely. What was the second question? I think
yeah, so was there anything about the policy language that made it hard to do solving? Would you change anything about the design of that?
Actually, some of the things that were hard was like the language evolved organically and over like 10 years. Like, when it was first designed, it was designed for a set of use cases, and the use cases kept adding on. So from an analysis perspective, it really you had to know, designing the edges, you had to know all the corner cases and all the semantic ways that things could combine, and that's just a lot of those. And in terms of like, hey, given now, what would we do different is, I know it's going to sound like a broken record, but it's like better abstractions, where like, you drive a car, you want the ability to pop the hood and see what's going on, but for the most part, you want to get from point A to point B. But I think it's a large. I don't think we could have designed the same abstractions today, 10 years ago, because what we know now, we couldn't have 10 years ago.
Yeah, no, that makes a lot of sense. So we are coming upon the end of time. Yeah, thank you, Neha, for joining us. This was super cool. I feel like, probably a lot of us use this access analyzer a lot and don't really know exactly what goes on under the hood. So this was really interesting. And I love what you're evangelizing about how the formal methods community should be really thinking about specifications as something we infer, and the yes, no should be something that developers or experts say. I mean, that's essentially the same journey that I went on, and that's why we're inferring API specifications, API models. This is what's going on with your system, because I noticed that it seemed like the same usability gap that you noticed, I was noticing too. So I think this is the next generation of, if we're going to get people using these correctness tools, these structured tools. So yeah, this was super cool. I don't know if Hangi has final questions or comments.
No, I mean, I think this is super interesting. I was really looking forward to this one. So thank you so much.
Yeah, thank you so much. And we'll send you a link to the Discord. No pressure, but sometimes people have extra questions that overflow into the Discord afterward.
Perfect. Awesome. Sounds great. Thank you for having me. This was a lot of fun.
Yeah, thank you so much. This is something, highly requested, highly anticipated by many. So yeah, thank you very much.
Yeah. Awesome.
All right, goodbye.
Bye. Thanks.
Yeah.
Sex, money, murder, DNA.